Right, grade 12s, we're on our third day of sinusoidal functions, and yesterday we did transformations as well. They were specifically translations, which are up and down, left and right. Today our transformations are stretches and compressions, where we stretch it upwards or we stretch it the wide way, so it's going to change the shape of our curve. So first of all, we're going to graph y equals sine x, y equals 2 sine x, and y equals a half sine x. So I'm going to start with the graph that I know. Y equals sine x, I know, or I have right in front of me. Minus 1 to 1, it starts at 0, 0, and it goes upwards at 90, back to 0, negative 1 at 270, back to 0. I hope these are starting to feel like you're getting to know them. Upwards, 0, downwards, 0, and start again. Not a super smooth graph. We're going to graph on top of that y equals 2 sine x and y equals a half sine x. So I know for my normal values, when x is 0, the key values that I used was 90, 180, 270, and 360. And I know for y equals sine x that I started at 0, 0. Sine x, it was my 1, 0, minus 1, 0. For 2 sine x then, I'm just going to take those y values and double them. So my red graph will be y equals 2 sine x, starts at 0, 0, it goes twice as high, back to 0, twice as low, which I can't quite reach, there we are, and back to 0. So it's going to have a steeper curve here. And the amplitude is now 2. Notice that the period hasn't changed. The domain is the same, the range has doubled. The next one, y equals a half sine x. I have halved everything in the original y equals sine x. So I still have 0, half of 0 is still 0, but I end up with a half here, 0, negative a half, and 0 when I have all those y values. So for y equals a half x, I still start at 0, 0, but at 90 I'm at a half. Halfway and back to 0 again. So when I put a number at the front, I have changed the amplitude. Let's look at y equals sine x, y equals sine 2x, and y equals sine a half x. So I'm going to start again by drawing the one that I know. Y equals sine x. So it's 0, 0, up at 90, back to 0, 180, minus 1 at 270, and 0 again at 360. So this is the sine wave that I know. There we are. Y equals sine 2x. I'm a little less sure of that one. So let's create a quick table of values. So in black, I'm going to have y equals sine x because I know those really well. 0, 90, 180, 270, 360. Values are 0, 1, 0, minus 1, 0. So for our y equals sine 2x, I'm going to put a 0 value in. Sine of 2 times 0 is still the same as sine of 0, so my first value is 0. Sine, I'm going to put a 90 in for x, so sine of 180. So this becomes a 0 as well. If I put a 180 in there, 2 times 180 is 360. This is a 0 as well. This isn't telling me enough information. I need some values in between. So let's have a look at when x is 45. For my former function, y equals sine x, sine of 45 is 1 over root 2 or 0.707. If I put 45 degrees into 2 times 45 degrees is 90, sine of 90 is 1. So this one becomes a 1 in here. I should put that in red. So the values, the missing values, are these ones in between. Sine of 135, it's 1 over root 2 as well, 0.707. But if I do the red function, 2 times 135 is 270, and there's my minus 1. So notice this pattern is condensed from the old black pattern. I'm going to have a 1, 4, 315. I'm going to have a 0 here, 0 there, minus 1, right in between 270 and 36. Oops, sorry, that went right there, 315. $180, $270, $225. So my pattern has been condensed. 0. I start at 0, 0. I'm at 1 already at 45 degrees. I'm back to 0 by 90. Minus 1 right in the middle. Back to 0 by 180. So I've done a complete cycle in 180 degrees instead of 360. Oops, right in between. High, 0, low, 0. So I have done 2 cycles in the space that it used to take me to do 1. So my domain and range are the same. I haven't made it any higher or lower. So the amplitude is back to being 1, not 2 anymore. But the period has changed. Instead of being 360 degrees, this time I do a cycle in 180 degrees. Let's have a look at sine a half. All right, if I put a 0, sine of a half times 0 is the same as sine of 0. So this is 0. I start at the same initial value. Not surprised at that. Let's look at 90. When x is 90, I am finding the sine of 45. The sine of 45 is 0.707. Let's look at 180. Sine of a half of 180 is the same as sine of 90, so that would be a 1. 270. Half of 270 is 135, and the sine of 135 is 0.707. And half of 360 is 180. I'm going to do this one again. These are my favorites. Half of 360 is 180, and the sine of 180 is 0. So I haven't even completed a whole cycle in 360 degrees. So the blue one is going to be the 1 values at 180. At 90, I'm only at 0.707. Same at 270 degrees. And back to 0. So I haven't even completed one cycle. So my amplitude is 1 for that one. I haven't made it any higher, but that period, instead of being 360 degrees, is going to be 720 degrees if I have y equals sine a half x. So if I put a number at the beginning of either sine or cos, I have changed the amplitude. Since amplitude is a distance from rest, then we would say that the amplitude is the absolute value of that number at A. So for instance, this first graph, my amplitude is going to be 3. If A is less than 0, we're going to have a reflection though. So if A is a negative number, we're going to have a reflection in the x-axis. In other words, it's going to flip upside down. So for the first one, we're going to have an amplitude of 3, and it's going to flip upside down. Let's graph it. I like to always draw the original function just in dotted lines first to get myself started. So I'm going to just condense the scale here a little bit. 1, 2, 3, -1, -2, -3. My original function starts at 0, 0 because it's sine. It hits a high at 90 degrees, so it goes up to 1, back to 0, -1, 0. And I'm just going to do that in dots. So that's my original y equals sine x. With a -3 at the front, it means I go as high as 3 and as low as -3, but it's upside down. So instead of up to 1, I'm going to go down to -3. So from 0, 0, I'm going to go down to -3. Through 0, instead of -1, I'm going to be up at 3, back to 0. So that roughly is my sketch. Really roughly. The next one is 2/3. So that's a positive number. It means it goes in the same direction as normal. And I am changing my amplitude to being 2/3 instead of the whole number 1. I'm going to draw a rough graph of cos x. So cos x starts at 1, passes through 0 to -1, back to 0 to 1. So it starts on a high, ends on a high. And I'm going to do it in dotted as well. Easier on the eyes. All right, there is our basic y equals cos x. If I have an amplitude of 2/3, my zeros are locked, my x-intercepts, because I have not changed the amplitude from 0, but I don't go as high, so I only start at 2/3 the height that it used to be, 2/3 the depth that it used to be, back to 0, 2/3. So my new function is still ups or ups. It's not been flipped upside down, but it only goes to 2/3 the height. And lumpy though it is, that is y equals 2/3 cos x. If you have, however, a number in front of the x, so not at the front of the function there, but in with the x, we don't change the amplitude. We have changed the period. And just like the translations that were in the brackets yesterday, anything that's horizontal is kind of strange. So we have changed the period. The period is normally 360 degrees. So if we put a number in here, that changes our period to become 360 divided by the value of k, absolute value of k. So if you have a number 2 in there, your period becomes 180. If you have a half in there, it becomes 720 because you have 360 divided by a half, which gets bigger. Let's try these two. Well, I'm going to graph, you're just going to look. Y equals sine -4x. Also need to mention that if k is negative, then you have a reflection, but not upside down. It's left to right. Reflection in y-axis. That is a flip. You'll be glad you're not drawing yet till tomorrow. Flip left to right. Okay, first one. Y equals sine -4x. So first thing that I would write down is that the period that used to be 360 is 360 over 4. So my period becomes 90. That means I do a complete up, down, sine goes up and then through 0, down, and back up again in 90 degrees instead of 360. So that's going to be fast. Also, k is negative. So there's also going to be a flip in y-axis. So I'm going to draw my y equals sine x and 0 90, 0, -1. Here we are. There's y equals sine x. My period now becomes 90. And so I'm just going to do this part of it first. I'm going to save my flipping till later. If it's 90, I have to go up, back, down, back again in 90 degrees. So I'm going to go from 0, all of that, and back to 0 there. I'm also going to have a 0 right in the middle, because that's what sine does. So we're going to go up, 0, down, 0. There you are. That's a period of 90, and we could keep going. And on it goes. That's what y equals sine 4x would be. Now if you have a flip across the y-axis, then everything's going to be backwards. So let's just draw it a little bit. So the normal one would do that. And if you're going to flip everything, be thankful you're not drawing this, it goes backwards. So instead of, I'm going to go back. So I've gone backwards, and I'm going to go backwards here. Oh, boy, that looks strangely like we flipped it upside down. But technically, we went left to right. The next one we have is y equals cos a half x. So we know that the period for this one is 360 divided by a half. If you divide by a half, it's like multiplying by 2 over 1, so it's going to be 720. I'm going to draw my basic cos function just to get myself anchored here. 1 minus 1. I know cos starts at high, goes through 0, low, 0, high. There we are, a regular cos function. This one has a very stretched period. So instead of high, down, low, back up again in 360, it will take 720 to get there. So it's going to take me a lot longer. I should be halfway through my cos cycle at 360. Putting it all together. And this is where you need to put a summary on your sheet. For A, if A is vertical stretch, if A is greater than 1, it's a vertical compression. If A itself is a fraction. So let's just write the English in here. If it's a fraction, it's a compression. That means your amplitude is the absolute value of A. If A itself is negative, then you have a flip or a reflection in the x-axis. So write yourself little notes that you know what these three things mean. And then we're going to look at K. K is horizontal. If K itself is a fraction, so we'll just write ourselves a little note here. If that K value is fraction, then you have a horizontal stretch. Everything horizontal is kind of weird. It's a horizontal stretch factor, and you would flip that fraction over. And we'll talk about that in a minute. If K is not a fraction, but larger, so the absolute value of K is larger than 1, then you have a horizontal compression. If k is negative, then you have a flip or a reflection in y-axis. So keeping that information handy, let's do a couple of examples where we're not graphing, we're just going to write down what has happened. One is incredibly easy and one is incredibly difficult. So the first one, y equals 4 cos x. I look and see that that number, which has been introduced into my equation, is before. It's not attached to the x, it's at the front, so it is a vertical. An up and down change is going to change the amplitude. The amplitude is normally 1, so in this case the amplitude is going to be 4. So it's going to go 4 above the 0 line and 4 below the 0 line. There is no negative, so it is not a reflection. And we would say that it is a vertical stretch, factor 4. My brain likes this terminology right here a little bit better. The amplitude is 4. I know how high to make that. The next one has a whole lot of stuff going on. And I'm just going to word that from left to right. The first thing that I see is the negative sign. And it is out the front of the cos function, so it is a vertical change. When we see negatives, it means it's a reflection. And if you have a vertical reflection, that means your ups go down and your downs go up. So it's a vertical reflection in the x-axis. I like to just say to myself, if I were ever trying to draw it, that it's upside down. The second thing that I see is the 2/3. It's also out the front of the function, so that 2/3 is vertical. And since it's a fraction, it's a vertical compression, factor 2/3. An easier way to think about it, I think, is to say that the amplitude is 2/3. So it no longer goes up to 1, it only goes up to 2/3. Then I see two things going on inside the brackets. The first thing is the 3. So that 3 is in with the x. That is our k value from our formula. So that 3 is a horizontal. And since that is not a fraction, it's a number larger than 1, it's a horizontal compression. Factor 1/3. And an easier way to think about that is that the period has changed. The period is normally 360. The period has been compressed. Instead of being 360, it's now 360 divided by 3, which is 120. So you've got that as a cos, so it starts high. High down to the lowest, back up to the high again, happens in 120 degrees instead of 360. The last thing that I see is that subtract 60, and we didn't look at any of those today. We looked at those yesterday. That is a shift horizontally. So horizontal translation, 60 to the right. Everything horizontal is bizarre. So we have all 4 changes written down, and that's what you're going to do on the chart that's in your handout, is to write in English what is going on with the equation. We'll try graphing tomorrow.